Alright, well let's do a problem that looks like this. This is a problem that's out of chapter 8.5. Okay, one thing that we need to remember is that you can always have 0 of something. Okay? Alright, we can have something that looks like that. But we can never have something of nothing. Okay? We cannot have this. Right? In other words, we can never divide by a 0. Okay? So whenever we're doing a problem like this, we have to keep in mind that after we figure out the problem, after we do the problem, we figure out what x is, we need to go in and plug that value back in for x to see if it's even possible. Okay? So this particular problem, if x equals a -1, we're going to be in big trouble. Why are we going to be in trouble? Well, put a -1 in for x. So -1 plus 1 is a 0. So we'll have 3 over 0, which is a big problem. So x cannot be a -1 in this particular problem. So let's hope we don't end up with a -1. If we do, we deal with it. Okay? I'm going to write that right up here. X cannot be -1. So what I want to do is, just like any fraction, I want to find a common denominator. You can see that 5 really well. Okay, well what's my common denominator here going to be? Well, I've got to multiply this number by 1 in the form of 5 over 5. Parentheses here. This one by x plus 1 over x plus 1. Okay, and this one here by 5x plus 1 over 5x plus 1. Oops. Got 1,000 today. There we go. Okay. So I've multiplied each of these by 1 in a different form. Okay. 5 over 5 is a 1. X plus 1 is a 1. X plus 1 over x plus 1 is a 1. And 5 times x plus 1 over 5 times x plus 1 is also a 1. So now I'm going to simplify these a little bit. So 5 times 3, 15 over 5x plus 1 plus 2. I'll distribute the 2 here. That would be 2x plus 2 over 5 times x plus 1 equals, distribute the 5 on the top, 5x plus 5 over 5x plus 1. Okay? So by doing this, by finding this common denominator here, I can essentially eliminate the denominator, because all these have a common denominator now. So essentially what I'm going to do is I'm going to multiply both sides of this equation by 5 times x plus 1. When it distributes through to each piece, it's going to disappear. It's going to leave me with 15 plus 2x plus 2 equals 5x plus 5. I go ahead and solve for x. So I'm going to subtract 2x, subtract 2x, subtract 5, subtract 5. Leaves me with 12 equals 3x. Divide by 3, divide by 3, so x equals 4. Okay, now we want to check our answer. We plug it back into the original. 3 over 4 plus 1 plus 2/5. And we're hoping that that's going to be equal to a 1. This would be 3/5 plus 2/5 equals 5. 3 plus 2 equals 5. 5/5, which is a 1. So it checks out.